In this video, we're going to convert binomial probability statements into normal distribution probability statements from 5.5. Before we can get into the applications of this, approximating a binomial distribution with a normal distribution, next video, then we're going to have to talk about the continuity correction factor that we need to make to convert a binomial statement that is discrete to a normal distribution statement, which is continuous. So if we have a probability of a binomial variable x that is between a and b inclusive, and even if we only have one of these pieces, it'll fall on one of these sides here. I'll show you that in a second. This is going to change to the probability of a normal distribution statement. I'm going to subtract 0.5 on the left, and I'm going to add 0.5 on the right. That is if these or equal to signs are there in the statement. If they are not, then we're going to have the probability of the binomial distribution statement x between a and b not included, like this. We're going to do the opposite of that, and we are going to add 0.5 on the left and subtract 0.5 on the right to get our normal distribution statement here. So let's go ahead and let's look at this first one. There's no or equal to sign, so I'm using the second rule. 103 is on the small side of the inequality symbol. X is bigger, so my 103 is a, since it's on the small side. I'm going to add 0.5 to that, and x is going to be bigger than 103.5. Now we have x less than or equal to 101. So 101 is my b that is over here in this one. So I'm going to add 0.5 to it, and I get x less than or equal to 101.5. Now x is less than 74. So strictly less than 74. 74 is b. In this situation, I'm going to subtract 0.5, and I get 73.5. And then we need to think about this in words. Less than is going to be fewer than. X is exactly equal to 102. So the way that I'm going to deal with that is say that 102 is between 101.5 and 102.5. So I subtract 0.5 from the left and from the right here. And it's going to be an exactly equal to situation, but I'm going to have to turn it into a between situation like that, where I subtract on the left and add on the right. Less than or equal to 121. So 121 is my right-hand boundary. So I'm going to add, and that's going to be, should be less than or equal to 121.5. Should be. This is the probability of getting at least. sorry, at most is less than, at most 121. So the following should be the same thing. 121 will be included in this statement like this, if we do that. So all right, that is it for this video. We'll come back next time and we'll talk more about 5.5. See you for the next video.